Hello everyone, our focus for this video is to be able to calculate the sine of 30 degrees, 45, 60 without the use of a calculator. Also the cosine of 30 degrees, 45 and 60 and the tan of 30 degrees, 45 and 60 without the use of a calculator. Right? And I'm going to show you the technique that you can use in this video. Now here on the board, if you notice, I have two triangles. One is an isosceles triangle and one is an equilateral triangle. So this one is the isosceles triangle. In an isosceles triangle, what we know that two of the length or two of the sides are equal. Also, two of the angles are equal. So here, this side and this side is equal. So I assume that the length of AC is 1 and also CB is also 1, right? And I know that angle CAB is 45 and also angle ABC is 45 degrees. Now I use the same idea, the properties of an equilateral triangle here. I know that three sides are equal. So I say that the length of each side is 2 meters, right? And I know that the three angles are also equal. So I say that this is 60 degrees, this is 60, this is 60. I know that the total amount of angle in any triangle must add up to give 180 degrees. So let's test that. 60 plus another 60, that gives us 180 here. And 45 plus 45, that's 90, plus 90, that's 180 as well. So we satisfy the properties of a triangle. Now, let's say that I want to calculate the height of this triangle, right? And I draw a line from this vertex here. Straight line. Touching the line or the line segment AC, right? And let's say that this line is perpendicular to this one. So it creates a 90 degree right there. And I don't know the height of this line, but it is, and I call it H. And I want to find out what H is, right? That's my aim here, to calculate what the value of H is. Now, if I split this triangle in two equal parts, creating two right angle triangles, then I can say that this angle has to be 30 degrees, right? Because if this is 60 and this is 90, then this has to be 30 degrees. Now I can use a popular theorem that you are familiar with to calculate the height of H, which is the Pythagorean theorem. But before I show you how to do that, let's say the point here where this line meets, we call it D. Which means that if this line cuts the triangle in two equal parts, it means that then AD would be half of the line AC. We know that AC is 2. That means from A to D has to be 1. Right? Now that we know that from A to D is 1, we can use Pythagoras theorem to calculate the height here. So if we use that theory, it says that the square of the hypotenuse AB would be the hypotenuse here. So that means 2 squared is equal to the square of the sum of the other two sides, which is 1 squared here, 1 squared plus 8 squared. Right? And we want to calculate the value of H. Then we can simply say that we can subtract 1 squared from both sides. So if we subtract 1 squared from both sides, we have 2 squared minus 1 squared is equal to 8 squared. Follow me? Now we want to find the value of H. That means we can square root both sides as well. So if we square root this side and we square root this side, that means this square root side cancels out this square, so we're left back with H. And H is equal to the square root of 2 squared minus 1 squared. So this is equal to the square root. But what is 2 squared? 2 squared is just 4, right? What is 1 squared? That is just minus 1, right? Now what is 4 minus 1? That is just the square root of 3, which is equal to H. Right? I'm not going to simplify my value because I definitely want the value to be in third form. So now I know that the height of this triangle is root 3. So we can therefore say the height of this triangle is therefore root 3. Right? Now, I don't know the length of AB over here. And I want to calculate the length of AB. I know that AC is 1. And I know that BC is 1 also. Now I can use Pythagoras theorem to calculate the value of AB. Because if I am going to use the endpoint, we can know that AB will form the hypotenuse. So therefore, AB squared is equal to AC squared plus BC squared. Right? Now, AB squared is what I want to find. So therefore, AB squared is equal to, what is AC? The length of AC is 1. So this is just 1 squared plus 1 squared. Right? Now, AB squared is equal to, what is 1 squared? 1 squared is just 1 plus 1. Right? So AB squared is equal to 2. Now, if I want to find what AB is, all I need to do is to square root both sides. So if I square root this side, and I take the square root of this side, this square root cancels out this 2. So AB is just equal to root 2. Right? And I will just leave my answer here because I want my answer insert. So therefore, AB is root 2, right? And that is what we know. Alright. So, let's see now if we can use these ratios to determine what sine 30 would be based on these triangles. Now, here we know that sine x is equal, or sine of an angle is equal to the opposite length over the hypotenuse, right? Now here, let's focus on this 60 degrees right here. We know that opposite to this 60 degrees would be this value over here, which is the height of the triangle, which is root 3. We know that the hypotenuse is this value, which is 2, right? And we know that adjacent to this 60 degree angle here would be our length here, which is 1. So if we draw a line from this 90 degrees box going here, we know that this is our hypotenuse. Clear? Now we want to determine the value of sine 60. Now we can say that sine 60 degrees is equal to the opposite length. What's the opposite length? The opposite length is root 3. So this is just root 3 over the hypotenuse length, which is just 2. So sine 60 is equal to root 3 over 2. Now, if you have a calculator, you can put it on your calculator. And you will realize that sine 60 is actually root 3 over 2. Now, let's look at cos 60. So let's say we want to find the value of cos 60, right? We know that it is the adjacent length, which is 1 here, over the hypotenuse length. So this would be 1 over the hypotenuse length, which is 2, which is just a half. And that is also true. You can take your calculator to test it to see if cos 60 actually give you a half. Let's say we want to find the tangent of 60. I want to find tan 60. Now tan 60 would be the opposite over the adjacent. The opposite here would be root 3. So this would be root 3 over 1, which is just root 3, right? Now, let's say that we want to find what sine 30 would be. Now, if you are focusing on this 30 degree, then opposite from this 30 degree angle is this side. So this would be the opposite, where 1 is. That means the hypotenuse remain the same, and the adjacent now become where root 3 is. So sine 30 degrees would actually equal to the opposite length, which is 1, over the hypotenuse, which is 2. Right? What do you think cos 30 would be? Let's see. Cos 30 would equal to the adjacent length, which is root 3 in this case. So this is root 3 over the hypotenuse length, which is 2. What do you think tan 30 would be? Tan 30 degrees would be equal to the opposite length over the adjacent, so it would be equal to 1 over root 3. Right? Now, let's switch to this triangle over here. And let's say that we want to find what? Sine 60. Sine 45 would be, sorry. Now, let's zoom in on this 45 degree angle. Doesn't matter which one you take, it will give the same thing. So, this side is the opposite side here. Now, according to this 45 degree angle, that means this side is the adjacent side. And it means that from this right angle going this direction, where root 2 is, would be the hypotenuse. Right? And we want to use to find what sine 45 would be. That means sine 45 degrees would equal to the opposite length over the hypotenuse, which is 1 over root 2. Right? We know that cos 45 degrees would equal to cos, it has to do with the adjacent length over the hypotenuse. So the adjacent length here is 1 over root 2. Right? And now we want to find what tan 45 degrees would equal to. And that would be the opposite length over the adjacent length, which is just 1 over 1, which is just 1. So that's just 1. Right? Now, you can take your calculator and put all of these angles on your calculator, and it will give you these values. Right? For some calculator, it will give you insert. But for most calculator, I wouldn't be able to give you insert. It will give you some decimal for it. But these values are accurate. Now, this is the technique that you can use to calculate the value of sine 60, sine 30, sine 45, cos 60, cos 30, cos 45, tan 60, tan 30, tan 45 degrees without the use of a calculator. Right? Now, and if you know about rationalization, we could also rationalize the denominator here, because if we rationalize 1 over root 2, that is the same thing as root 2 over 2. So sine 45 is root 2 over 2, or 1 upon root 2. And also cos 45 is the same thing as root 2 over 2 as well. So that's a point to note. And here, tan 30 is the same thing as root 3 over 3, because we could rationalize the denominator. Now, there's something interesting happening between these angles. Note here, if you observe where you have sine 30, right? You can therefore say that sine 30 degrees is equal to cos 60 degrees, because sine 30 is equal to a half, and also cos 60 is equal to a half. What is that saying? Now, these two angles, if you look at 30 degrees and 60 degrees, they sum to give 90 degrees, which means that they are complementary angles. So, once you find the sine of an angle and the cos of an angle, which makes them complementary, they will always give the same value. Now, look at sine 60 here. Sine 60 is root 3 over 2, right? So let's just look at sine 60. So sine 60 here is equal to root 3 over 2. And also cos 30 is equal to root 3 over 2. They are what? They are complementary angles, right? And clearly from the isosceles triangle, you could clearly see that, because here sine 45 give you 1 over root 2 or just root 2 over 2. And also cos 45 give you 1 over root 2 or root 2 over 2, which means that they are equal. So another conclusion that you can draw here is to say that sine 45 is equal to cos 45, and that is also true. And all of these are helpful when you're doing trigonometry, right?